fellas, welcome to my channel. Today I'm going to take you through the project that I have been building, a system called GAIA, which stands for Generative AI Environmental Impact Analyzer. This platform is designed to bring transparency, sustainability, responsibility into the world of generative AI. The generative AI is becoming extremely powerful, but that power comes at a hidden cost. A single GPT-4 query can consume up to 15 to 20 times more energy than normal Google search. And large models require huge GPU clusters that run on massive electricity. According to IEA, the global AI electricity usage may surpass Japan's entire annual usage by 2030. Not only that, the cloud regions around the world vary massively in a carbon intensity. Some regions emit around 40 grams of CO2 per kilowatt per hour, while others emit more than 900 grams for the same energy. Yet, today users have zero visibility into how much energy or how much CO2 their AI is creating. Organizations can track the flops, carbon cost, or model efficiency. Without transparency, AI consumption keeps rising, and so does the environmental footprint. So, why does it? Why does it matter to us? Enterprises today are under strong pressure to meet the ESG goals, that's environmental, social, and governance reporting. They need a real measurable and variable emission data, not estimates, no, not the assumptions, only the real numbers. The customers are also becoming conscious. They want transparent, sustainable AI services. Without optimization and monitoring, AI usage and its carbon footprint will keep on increasing exponentially. So, for that purpose we come across the solution, the GAI, Generative AI Experiment Environmental Impact Analysis. So this is where the GAI comes in. GAI is a sustainability intelligence layer for generative AI. It turns every AI request, every prompt, and every model call into measurable energy and CO2 matrix. It acts like a personal environmental auditor for your generative AI usage. As soon as the user enters the prompt, the GAI captures the metadata like duration, token count, model characteristics, and flops. It then converts those flops into energy consumed and CO2 emitted based on the carbon density of the region you are using. So, how it does help to reduce the AI environmental footprint? The GAI doesn't stop at measuring the impact, it actively helps the users to enterprise reduce it. And first, GAI can suggest lower emission model alternatives. For example, instead of using GPT-4 for basic requests, GAI must recommend GPT-4 Mini or Gemini 1. This is alone can cut the energy drastically. Second, GAI performs Second, the GAI performs a prompt optimization. It analyzes your prompt, detects the redundant unnecessary words, and applies the compression rules without changing its meaning. This can reduce token usage up to 40%. The third, GAI recommends the greener cloud regions by checking live carbon intensity data from the grid. If another region is clearer than at that time, GAI suggests switching, saving both the cost and emissions. Finally, GAI reduces the redundant inference operations by recognizing the repeated prompts and suggesting the cache and batch buffering. So let us see the mobile workflow. So GAI mobile application provides a simple, intuitive experience. User starts by typing their prompts and choosing their model. The application processes the request and computes the energy usage and CO2 estimate and shows it directly on the dashboard. If improvements are possible, GI recommends or optimized prompts, alternative models, or greener regions. The users can view the ESG ready reports, download the summaries, and track their historical energy and carbon logs. This makes the GI extremely useful for the enterprises, research team, and anyone who wants a responsible AI usage. So, what happens in the behind the scenes? The GAI is an advanced optimizer engine. It has three optimization flows: the model optimization, prompt optimization, and region optimization. The model optimizer checks the flops, power efficiency, and energy profile. For each model, it recommends a greener alternative. The prompt optimizer analyzes the structure of the incoming prompts and produces a cleaner, shorter, but semantically identical prompts. And the region optimizer uses the real-time carbon intensity data to compare different cloud regions and recommend the greenest location to run the request. Together, these three modules provide a complete sustainable optimization system. The Let us see the GAI backend is built, how the backend is built. So the cloud backend microservices, it includes the carbon intensity API, a model profiles a database, energy estimation formulas, and security layer, and full integration layer for models like OpenAI, Gemini, Cloud, and Azure OpenAI. On the mobile side, GI is built using the Android Firebase, Python services. Additional components include flops estimation engine, prompt compression engine, and room database storage analytics. So why it matters? If we continue using generative AI without transparency, AI will become the largest and the fastest growing source of energy consumption. GAI helps to solve that by providing the visibility, accountability, efficiency. It reduces the cost, reduces the CO2, and promotes the sustainable AI adoption across the teams. With ESG reporting becoming mandatory in more countries each year, GAI positions enterprises as responsible, transparent AI providers. So, GAI imagines a future where the generative AI request is measurable, low carbon, and responsible. It empowers enterprises to make the AI sustainable without sacrificing the performance and innovation. If you are excited about the sustainability of AI, we can see the full project in the next video. Thank you for watching. Let's build the greener AI future together.